Hi everyone, so this is lesson 3.1, identifying pairs of lines and angles. So in this lesson, we're going to go over special line pairs, special angle pairs, and some more new postulates. So let's start with parallel lines. Parallel lines are lines that lie on the same plane. They lie on the same plane, but do not intersect. They must meet these two conditions, okay, to state they are parallel. Okay, let me show you an example. Look at this diagram here. Line M and line N are said to be parallel. They are marked as parallel. How do I know? This marking right here, okay, you can use arrows like that or little triangles, close it up and turn it into a triangle. And these are the marks that we use to indicate two lines are parallel. Here's another example right here. So I want to show you this example so you can see that we differentiate between one set of parallel lines and another by using same amount of matching arrows. Okay, so these two lines are parallel to each other. These two lines are parallel to each other by the indicated matching marks. Okay, now let's look at skew lines. Skew lines are lines that are on different planes and they never intersect. So when you have a homework question and they ask you if they are skew, make sure you check they are on different planes and they don't intersect. They must meet these two conditions. Okay, let me show you some examples. Line AB and line FH are skew. They do not intersect and they are not on the same plane. Excuse me. AC and AC and EF are also skew. They're not on the same plane and they do not intersect. And let me show you one more example of skew lines. Line K and line M are skew. Line M is on plane T. Line Q is not, so they're not on the same plane. And line M and K do not intersect. So line K and M are askew. Okay? When parallel lines are parallel, we use these markings again on a diagram to show they're parallel. But when we want to indicate they're parallel in written form, this is the way we do it right here. So I'll write it out for you. So line M is parallel to line N. So we just use these two parallel lines side by side like that to indicate two things are parallel. They could be two planes, like in this case here, in this diagram, plane T and plane U are parallel to each other, and this is how we would indicate it. Planes P and T are parallel planes, and this is how we would show it. T is parallel to U. Okay? All right, let's keep going. Let me go back to the diagram. You should know one more thing. Since these two planes are parallel, they told us they are parallel right here. Since they are parallel, that means any line that I can draw in U will be parallel to plane T. And it's true for plane T also. If I draw, well, this line here is in plane T. Line M is parallel to line U. So any line you can draw in one plane, it will be parallel to the other plane because the planes are parallel to each other. Okay, you should also know that segments and rays are parallel if they are part of parallel lines. So if they lie on parallel lines, those segment and rays are also parallel. All right, let's put this to practice. Use the diagram to answer the questions below. Think of each segment in the figure as part of a line. Which lines or planes in the figure fit each description? Because we want to find the line that's parallel to CD containing point A. So we want it to be parallel to this line CD, but we want that line to also contain point A. Okay, this line HJ is parallel to CD. This line EF is parallel. AB is parallel, but the only correct answer has to be AB because we want the line that's parallel and contains point A, and that's only AB. Okay, let's look at the next one. We want lines that are skewed to CD containing point A. So here's CD. We want it to be skewed, so it can't be in the same plane, and they must not intersect. So we can look over here, and it has to contain, that line has to contain point A. So I see AH here, that line is skewed because they don't intersect and they're not on the same plane. So AH is skewed. Is there another line that is skewed that contains point A? What do you think? There is another line right here. It doesn't intersect and it's not on the same plane. So it meets the definition, and that's A, what was that? G or J? G. All right, let's keep going. Lines perpendicular to CD containing point A. You want it perpendicular. So they must meet at a right angle. So here's CD. We need one that's perpendicular, so it should be marked. This line here is perpendicular. It is marked, and it does contain A. So it has to be A, what is that letter? AD. So line AD is perpendicular, and it contains point A. All right, next one. Planes parallel to plane EFG containing point A. So EFG is the bottom plane, and it has to be parallel to the top plane. Okay, which is plane A, B, and C. So ABC plane, ABC, and it does contain the point A. Okay, let's keep going. Are these lines skewed? Well, let's look. ZV, this line, and WB. Are they skewed, yes or no? If you said yes, you're right. They are on different planes and they don't intersect. Okay. What about YD and VW? Do they lie on the same plane? No. Do they intersect? No. So they are skewed. The answer is yes. 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 Okay, now we're talking about postulates, more postulates. It's postulate 13, parallel postulate. It says there's exactly one line through P parallel to L. Let's sketch that out. So if you have a line, let's call it line L, and you have a point that is not on the line, we'll call it point P. There's exactly one line that can be sketched out that would go through P and that would be parallel to line L. How do we show they're parallel? We use arrows. Same number of matching arrows. So I'm showing, and I'll call that M. So line L is parallel to line L. All right, let's keep going. Postulate 14, perpendicular postulate. All right, so this says there's exactly one line through P perpendicular to L. Let's sketch it out. So you have a line. We'll call it L. And you have a point that does not lie on that line. Okay, there's exactly one line that will, let's call this point P. There's exactly one line that will go through point P that will be perpendicular. Sorry, let's sketch that again. So there's exactly one line that goes through P that will be perpendicular to line L. Okay, we'll call this line L. So line L is perpendicular to line M. All right. All right, now let's talk about special angles. Special angle pairs are formed when two lines are cut by a third line, which is called a transversal. A transversal is a line that intersects two or more coplanar lines at different points. As a result, we end up with four types of angle pairs. We end up with four different types of special angle pairs. These angle pairs have special names, and you must be able to identify them and name them. Okay, so let's look at these four different special angle types. So you have this line, and they are cut by a transversal. They call it T in this case. Okay, when this happens, we have special angles are formed. Let me erase. These two angles in this position are called corresponding angles. They are on the same side of the transversal, and they are above the lines. These two angles in this position here, okay, they are on opposite sides of the transversal. They're on opposite sides of the transversal, and they're inside the lines, inside. So we call them alternate interior angles. These two angle pairs right here, 1 and 8, they are outside of the lines, and they are on opposite sides of the transversal. We call them alternate exterior angles. And then we have this pair, 3 and 5. They are inside the two lines on the same side of the transversal. We call them consecutive interior angles. Okay, let's see if you can identify and name these special angle pairs corresponding. Okay. Angle 1 and angle 5 are corresponding. So angle 1 and angle 5 are corresponding. Also, angle 2 and angle 6, angle 2 and angle, let me erase this. I don't like where I'm putting this. Let me put it down here below and try to organize it a little bit better for us. Okay, corresponding. Angles. That would be 1 and 5, 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Okay, now let's do alternate interior. Alternate I'm going to abbreviate here. Interior. Angles. Alternate interior, that would be 5 and 4. Angle 4 and 5, or 5 and 4, however you want to say it. And 2 and 7. Okay, and that's it for alternate interior. Let's do alternate exterior. One and 8, sorry, 1 and 8, angle 1 and angle 8, and also angles 3 and 6. Okay, finally, the last special pair. Consecutive. Interior. Angles. That would be 4 and 7. They are inside, on the same side of the transversal. Angle 4 and angle 7. And then you have another set on the other side, 2 and 5. So you have to be able to name them and identify them. All right, so let's get some practice. Classify the pair of numbered angles. So you have this angle. Hold on, let me use different markings. Let me just circle. Angle 1 and angle 5, okay? They are what? Corresponding. That is correct. Angles. All right, what about 2 and 7? What do you say? Alternate exterior angles. That is correct. What about the next one? Alternate interior angles. All right, let's keep going. You're doing more of the same here. Identify the angles, the angle pairs. 5 and 1. 5 and 1 are corresponding angles. Corresponding. And I'm just going to abbreviate corresponding angles. Let me use the angle symbol. Okay, what do you think about 19, 11, and 13? 11 and 13. They are inside on the same side of the transversal. They're consecutive angles. All right, what about 6 and 13? That's the same thing, right? Consecutive angles again. They're on the same side of the transversal and inside between the two lines, so they are consecutive. Okay, what about 10 and 15? 10 and 15. You said alternate exterior angles. You are right. Alternate exterior angles. All right, 22. Angles 2 and 11. 2 and 11. They're inside these two lines, and they're on opposite side of the transversal. Okay, that makes them alternate interior angles. Alternate interior angles. Okay, 23. 8 and 4. That's this angle and this angle right here. They're below the lines on the same side of the transversal. They are corresponding angles. Okay. Here's some more. You try these independently. And this concludes this lesson 1.3.